Hello everyone, my name is Omer and welcome to Abusing CI/CD, top ways to reach production. Just a moment before we make a more formal introduction, let's see what is the agenda, what will be the main goal for this talk today. Okay, so most of you probably work with CI/CD pipelines on a daily basis, right? Nearly any company that develops software have a pipeline used to build, test, and deploy their code. Not that you need one, but a proof for how common CI/CD is today can be found in the statistics of Jenkins, which surprisingly is still the most widely used build system in the world today. And you can see in the graph that today there are 58 million pipeline executions in Jenkins instances per month, which is pretty amazing. And it nearly doubles itself every 2 years, this number. It's kind of the Moore's law of build systems. And hackers are aware of these statistics. So today, you will see how attackers are using your pipelines to reach production. So my name is Omer Gil. I have a background of around 14 years in multiple security disciplines, both defensive and offensive, like hacking to web applications and cloud environments. Today, I'm the head of research at cybersecurity. We are a startup creating a solution to reduce the friction between DevOps, security, and software developers. We have a platform that analyzes development technologies and framework in use across your CI/CD pipelines and secures both the CI/CD systems and processes, as well as the code and configuration flowing through the pipeline. Now, what led to this talk is the research that my team conducted during the past year around how attackers abuse CI/CD systems, and I'm here to share the insights with all of you. So let's begin. We'll start with a short background. So with the rise of DevOps and cloud computing, where everything is automated and deployed fast and easy, a new attack surface was introduced in the last couple of years, which is reaching the organizations what we call crown jewels, the production systems. This is where the data is at of your customers. This is where your money is at, and you probably all want to protect it. Now, some of the most common attack vectors against this production environment could be one example is breaching the perimeter, like exploiting a port left open in a publicly exposed server, or exploiting SQL injection in your web application, for example. It could be abusing cloud misconfigurations, like an S3 bucket left open to the internet without requiring any authentication. And another example would be exploiting workstations and endpoints, like taking control over an engineer's workstation, and from there moving laterally in the internal network, trying to access sensitive production systems. Now, as these attack vectors became more mature and common, security also adjusted with methodologies and security systems, providing prevention and detection capabilities. And there are actual positions today with the purpose of dealing exactly with these threats, like DevSecOps engineers, cloud security engineers, and AppSec engineers. So as the attackers are having a hard time exploiting these vectors today, they are aware of how popular CI/CD is, as you just seen in the graph. And recently, especially during the past year or two, we see an evolving attack surface, which is abusing the software delivery process, taking advantage of the connectivity and processes involved in shipping application and infrastructure code to production. Now, you might ask yourself if your CI/CD pipeline is secure. You probably have various security controls there. You probably enforce 2FA on your source control management system, your SCM, and you require pull request approval before introducing new code to the main branch. You have a container security solution, and you have access controls implemented. You restrict network access, and even do the impossible mission of reducing production permissions. And you log everything. But is that enough? Probably not. I mean, these are great security controls that many organizations use, but if you'll have a look at some of the more known security hacks and incidents from the last year or two, you can see that even big companies that invest a lot in security got hacked through their CI/CD systems. One example would be SolarWinds, a huge company that were hacked with one of the largest and most sophisticated attacks ever. Their CI system was compromised and then was introduced with code that was later distributed to their customers. Another example would be CodeCov, a code coverage tool. You run a script that they provide you in your CI. They have thousands of customers, and this script, their server was hacked off CodeCov, and this script was appended with malicious code that was running in thousands of in the pipeline, in the CI/CD pipeline, sorry, of thousands of their customers, stealing credentials from these pipelines. And another example would be the popular NPM packages that were hijacked, like RC, Koa, and the UA parser JS packages to steal credentials from CI/CD pipelines. So what we see in all of these hacks that we saw in the last year or two is that hackers that run code in your CI have access to your production. You might think, hey, I mean, my CI you can't run code in my CI as an external attacker, right? My CI is internal, it's behind the firewall, it has authentication, and maybe you implemented the RBAC, role-based access controls, and the hackers are like, okay. So let's move on and get to the point and start talking about how hackers can hack your pipelines. Okay, so here we see our basic pipeline. There's a developer here with write permissions on a repo, which is linked with a Jenkins pipeline, which eventually, after it tests and builds the code, it deploys it to the production, which is the crown jewel, the main target of the attacker. Now, here comes the attacker. You can easily identify it because it's red and it wears a hoodie. And we know that it wants to target production. You want to have direct access to this environment. But as we said a moment ago, it might not be so easy to carry out because we know that today there are many security controls and people that want to prevent exactly this kind of scenarios from happening. So the attacker will try to look for another path to reach production. And he knows that there's probably a CI/CD pipeline leading to production starting from this developer. So maybe if the attacker would succeed compromising some authentication method of this developer to the repo, to the source control management system, he might be able to move between the different stages of the pipeline until it reaches his goal. There are many authentication methods used for SCMs, for user accounts. There's SSH keys, access tokens, credentials for the system, and many others. So the attacker just needs to grab one of them in order to have his initial footprint in the CI/CD. But it's still quite challenging, right? A user which is probably security aware, just one with write permissions on the repo, it might be a bit hard. But as we know, this developer might be not the only one who works on this project and has write permissions on this repository. There's probably some other team members working on this project. And now the attack surface for the attacker expands a bit, right? He can compromise each of these 4 team members, and from there, proceed with his attack. But still, it's still a bit challenging, right? It's just 4 people. But as we know, even though this is the team working on this project, we know that maintaining permissions in the SCM is a big mess. And probably not just this team has permissions to the repo, but many other people in the organization. What I've seen after inspecting tons of CI/CD environments for different organizations, I've seen that usually, like the standard case, is that in a medium-sized organization or bigger, there are dozens of or hundreds or thousands of different user accounts with permissions to nearly all of the repos. And I'm talking about write permissions in many cases. So it's a huge mess, and it's hard to maintain securely. And then the attacker just need to target one user in order to have the initial footprint in the CI/CD and start moving between the stages to reach his goal, to reach production. Now, in this talk, we won't focus on how attackers can compromise developers' accounts. That's a topic for another talk. I can talk hours about that, Now, the important thing is that it happens all the time. And our focus today is on the possibilities of the attackers once they compromise a user account in the source control management system. Okay, so now in this phase, the attacker gained write permissions on the repo. He doesn't have direct access for the CI, definitely not for production, just write permissions on a specific repo linked with a Jenkins pipeline. Now we'll cover 4 attack vectors that the attacker can use in order to reach production through his initial foothold in the repository. And we'll start with the first one called PPE, which is poison pipeline execution. This attack vector has 3 variants, and we'll start with the first one, which is direct PPE, or direct poison pipeline execution. So as I said, the attacker only has write access to the repository, and he cannot see or access the CI or production. So he starts looking at the contents of the repository. Jenkins file, most of you probably know, if not all of you, is the CI configuration file that defines the stages, steps, and commands that will run when the linked pipeline on Jenkins, in this case, will be executed. So that sounds interesting. If it defines commands that will run in Jenkins, the attacker can insert malicious commands in the Jenkins file, which will execute malicious code later on Jenkins. So the attacker wants to directly push this malicious Jenkins file to the main branch, which probably runs in the pipeline, but it's not so easy to carry out, again, right? Because there are branch protection rules, one of the most popular security controls out there. Any organization use it to prevent against direct push of code to sensitive branches. So if the attacker would try to directly push to the main branch, he won't be able to do so. But what about pull requests? Pull requests also trigger pipelines. This is eventually unreviewed code that we also want to build, test, maybe scan for security issues. It looks like an interesting opportunity for the attacker. So the attacker steps into the Jenkins file code. Let's see it. So this is our Jenkins file. You can see here the different stages. There is the build stage and the test stage. And inside the build stage, there are AWS credentials stored on Jenkins, which are loaded into memory in runtime and are stored as environment variables. And then there are some make commands that are ran in the pipeline. What the attacker can do is to modify this Jenkins file to exfiltrate these environment variables, which include the AWS credentials, to a remote server that he controls. Now let's have a look at the attack flow. So the attacker creates a pull request with a malicious Jenkins file that we've just seen. Now, with the creation of the pull request, if this is how the CI and pipeline are configured, of course, the pipeline is triggered, fetching the code from the repository. Now, along with the code, the Jenkins file, the malicious one, is also fetched from the repository, but the malicious one that the attacker created in the pull request is the Jenkins file, is the CI configuration file that practically defines the pipeline stages. So the malicious Jenkins file runs in the pipeline, and now the bad lines of code run in Jenkins. The credentials are sent to the attacker's controlled server, and the attacker can now access AWS. Now, of course, that he doesn't necessarily send the credentials to his server. He can also directly perform malicious commands and actions against production. In practice, the attacker has the identity of the pipeline, so he might be able to access sensitive systems from there. But in this case, he decided to exfiltrate the credentials. So this is direct PPE. In direct PPE, the attacker directly modifies the configuration of the pipeline and poison the pipeline, even though he doesn't have access to the CI directly. Now, you might think that in order to execute a direct PPE attack, the attackers, they need to obtain access to a developer account. And if attackers already gain access to a developer's account, there are many other attack vectors to execute, like moving laterally in the network, accessing production directly, or other actions. But I'd like to remind you that the first slides in this talk today, that today many efforts are being made to reduce the attack surface of other vectors that we've just seen in the beginning. So they do it to increase prevention and detection capabilities. And along with that, there are really poor capabilities in the CI/CD for visibility and for prevention and detection of these kind of threats. So I'd like to ask you, if a direct poison pipeline execution attack is executed in your environment, would you have the ability to know about it? And the answer is probably no. So security and DevOps decided to protect against the modification of the CI configuration file when running unreviewed code, like in pull requests or unprotected branches. Now, this can be done in different ways, like always fetching the Jenkins file from the main branch, or storing the Jenkins file in a different repository. So if someone decided to do that, indeed, you would be protected against direct PPE. But does that mean that your environment is secure against poison pipeline execution attacks in general? Of course not. Otherwise, I wouldn't be asking. So let's move on to the second variant of PPE, which is indirect PPE, or indirect poison pipeline execution. That's our second attack vector we're going to talk out of 4. So the attacker can't change the Jenkins file now, right? Because it's protected. So he takes a look at other files in the repository, and he sees the make file. If we'll jump back to the Jenkins file, which is, again, now protected, we saw before that in the build stage, when credentials of AWS are loaded as environment variables, the make build and make clean commands are ran. And as you know, the make commands reside on the contents of the make file. So let's have a look at this. We can see here the different functions originally defined in the make file. And these are the definitions of the different functions in use. We can see the build, plan, and clean functions here. What the attacker can do is to modify one of the functions that run there, and modify the build function in this case with the same command as we saw before. Now, the attacker creates a pull request in order to execute indirect PPE. He creates a pull request with the original Jenkins file because he cannot change it, but with the malicious make file. The pipeline is triggered and fetches the code from the repository, including the malicious make file. The Jenkins file starts running the build stage, loads the AWS credentials into memory, make build command, which is now executing malicious commands that send the credentials to the attacker that can now access production, AWS in this case. So rather than, this is indirect poison pipeline execution attack. Rather than poisoning the pipeline by inserting malicious commands directly, as in direct PPE, into the pipeline definition file, in indirect PPE, the attacker injects malicious code into files referenced by the configuration file.
Hi, we are Eficode, and we organize the DEVOPS Conference. What developers really want is to see their software live. CI/CD minimizes the time from idea to software delivery. We would love to speak with you to learn how we could help you to remove the pain and uncertainty from your software development lifecycle. You can find us at Eficode.com. The links are in the description. And have a great time with the DevOps Conference talks.
Okay, so now we'll move to the third and last variant of PPE, which is public PPE, or 3PE in short. Now, in this scenario, the attacker starts from a different position that we've just seen. The attacker didn't obtain write permissions on the repo, and in this case, there is a public repository linked with a Jenkins pipeline. Public repositories, like in open source projects, they allow any user to contribute, usually by creating pull requests and suggesting changes to the code. These projects can be linked with a CI to automatically test it. So to execute a PPE attack, whether direct or indirect, the attacker can fork the repository. Then it can modify the Jenkins file, just as we saw a moment ago with direct PPE, and then open a pull request to suggest these new changes to the main branch in the original repository. What will happen is that if a pipeline is triggered insecurely, etc., the pipeline would be triggered with and defined by the malicious Jenkins file. Credentials will be sent to the attacker, which can now access AWS. So that's public PPE, or 3PE. If the pipeline of a public repository runs unreviewed code suggested by practically anonymous users from the internet, it is susceptible to a public PPE attack, depending on how secure the configuration of the CI is. And there are a lot of good configurations that can be done to prevent against this. So let's move on to our last attack vector for today, which is different from PPE. And this will be bypassing required pull request reviews in GitHub. So let's see what this is. So we are back in the place where the attacker was just a moment ago. He has write permissions on the repo, on a GitHub repo specifically, linked with a Jenkins pipeline. Now, let's say that the attacker wants to introduce malicious code to the main branch because he wants to deploy malicious application code or infrastructure, or executing a direct PPE attack by directly pushing malicious code to the main branch. But it's not so easy because, again, there are branch protection rules. So if the attacker would try to push directly to the main branch, he will fail. So maybe he can consider executing a direct PPE attack over a pull request, like we've just seen. But let's say that in this scenario, the Jenkins pipeline is not executed by the creation of pull requests. So direct PPE is not an option with these branch protection rules in place. The attacker can be naive and create a pull request with the hope that someone would approve his malicious PR. But of course, that if he would try to fool a developer to approve his malicious code, it would probably fail. So now the attacker has an open pull request with his malicious code, but he cannot merge it to the main branch, or can he? So this is where GitHub Actions steps in. But why am I asking you about the GitHub CI solution, which is not even in use in the organization? That's a good point. So there's something interesting about GitHub organizations, that any GitHub organization has GitHub Actions installed and turned on by default. And any user with write permissions on a repo can create a workflow file. This is how Actions pipelines are defined. And these workflows will immediately be executed. So it's like an interesting direction for the attacker. So what the attacker can do with this information? He can create a workflow configuration file as part of this pull request, a workflow.yaml file. But what can he do with it? Let's have a look at the content of this file. So the developer can create this file. As you can see in line number 3, it's triggered on pull request event. It will be triggered when he will create the pull request. On line numbers 5 and 6, the developer can define if the workflow would run with read or write permissions against the repository, which is interesting. And another thing you should know is that a workflow runs with a GitHub Actions bot user. and not with the identity of the developer that triggered the workflow. So you can see at the bottom of the file that the actual command which will run as part of the workflow is to access the pull request endpoint in GitHub API and approve the pull request that triggered the workflow from the beginning. It's a big mess, right? Let's see the actual attack flow. So the attacker creates a pull request with his malicious code and YAML workflow configuration file. This configuration file tries to approve the pull request that the attacker just created, and it succeeds. The attacker gets the approval he needs from the GitHub Actions user, which is another user than the one he compromised. So now the attacker has the desired approval, and he can merge the code in the main branch. That's pretty amazing. You can just bypass branch protection rules in GitHub by default in any organization. Now, malicious code is executed on Jenkins if DirectPP was the desired path, or application code is delivered straight to production if that's how the pipeline is built, and this is what the attacker decided to do. Actually, we reported this vulnerability to GitHub a few months ago through their bug bounty program. They acknowledged it and released a fix that allows you to restrict action reviews from being counted towards approval in pull request. You just need to know that it's not set securely by default in existing organizations. So I recommend you having a look at your organization settings and uncheck this new setting. Okay, so we are nearly out of time. I'll summarize quickly. We talked about 4 attack vectors today, 3 types of PPE. We had direct PPE, in which we alter the CI configuration file. We had indirect PPE, where we alter a file used by the CI configuration file. And we had public PPE, or 3PE, where PPE, direct or indirect, is exploited through public repositories. And we saw how we can bypass required pull request reviews in GitHub Actions, using GitHub Actions. So to summarize, pipeline jobs are practically code execution as a service. This is how you see it, but this is also how attackers see it. And I would like to end this talk by leaving you with one question to ask yourselves. How far can an attacker with your permissions go? So with the famous words of Hattori Hanzo, I'd like to thank you for being here today. I really appreciate it. You're welcome to the cybersecurity blog, very interesting materials on CI/CD security, and you're more than welcome to follow me on Twitter. Actually, next week we're going to publish something big that, in my honest opinion, any DevOps and security engineer would be glad to read. So follow and stay tuned. And thank you. I'm available to any questions you might have.
Cool. Thank you, Omer. Well, as with all talks before, we're going to use the Q&A panel on the right to enter the questions. So I see one question already, but please, if you have a question, go there and enter them. We'll take the next 5-ish minutes to allow Omer to answer some questions before we continue with the program. So one question from Zenit. It's about, he describes a pipeline setup in Bitbucket, and he wonders if you can find a weakness in it. So he says, like, if you have a Bitbucket pipeline where you cannot push to master, you cannot merge before there's a review, and you can only deploy from prod from the master branch, is there a possibility that one of the attacks you described can actually work?
So you said no push to master, no merge before review. So it really depends on there are many different parts that we need to have a look at to understand this. But in general, I think that it will be possible without knowing all of the moving parts. Because, for example, what we've just seen with indirect PPE, if the pipeline, for example, is running over, in any case where the pipeline is running over unreviewed code, and this is the case in many cases, this is what happens, like in pull requests. If the agent where the pipeline is executed can access secrets or sensitive systems that unreviewed code, which is risky for unreviewed code to access, this is where you are exposed to these kind of threats. So there are different mitigations against these kind of attack vectors, but the best thing that I can offer as a general suggestion is to make sure that unreviewed code is never exposed to sensitive data or systems.
Cool. Check. Yeah. Another question came in from Scene. Are the vulnerabilities you highlighted compounded if the org is exclusively using GitHub Actions for CI/CD?
So all of these vulnerabilities, so poison pipeline execution, PPE, the first three attack vectors are relevant for any type of CI/CD system and any kind of combination that you might have between an SCM and CI and production. The last one, where you can bypass branch protection rules, this is only, as far as I found by now, is only applied for GitHub Actions. But again, not even if you're not using GitHub Actions, even if you're just using GitHub, you have any type of CI, Actions, Jenkins, Circle, you are potentially vulnerable to this bypass.
Cool. So I was wondering, what if you're using your CI for security scanning? Are there ways to kind of shield, to break out your CI in multiple bits, such that you have kind of a secure environment and a more to do the security check and then do it every second bit? Is that something you see people do?
I'm sorry, can you repeat the question again?
That you split your CI into two bits. One which is kind of just to do the initial security testing, and the second one to actually execute your normal CI pipelines to kind of have a testing ground before running any code.
Yeah, for sure. So splitting the different stages for a hardened server that can't reach sensitive information for your unreviewed code, and then using other agents or environments for code that you trust because you already scanned it or you reviewed it manually by other developers. That's a great security control. But I must emphasize that scanning your code won't necessarily find all of these. You probably won't find all of these. You probably won't find a clever attacker which is already in your network. So this is why we recommend to always not avoid running unreviewed code in any part of it in the pipeline, any stage in the pipeline, with access to sensitive assets.
We have more questions, and we have a question from Robin.
What are the protections/workarounds for PPEs?
Okay, so actually there's a bunch of them. One of them would be, again, not running unreviewed code with access to sensitive information, but it's not enough. There are other ones, like using branch protection rules correctly and know exactly which branches are triggered in the pipeline. So I think we don't have enough time to cover all of the protection mechanisms against it. But I will say that I released, along with Daniel, our CDO, we released a long blog post about poison pipeline execution. And it's on our website in the blog there. So you can reach out there, read the blog. It's all there. And you can also contact me for questions about it. I will be glad to address.
Wonderful. We'll take one last question, and it's from Zenith.
What do you recommend for security scanning for Bitbucket pipeline?
So it's a great question, but it depends what do you want to scan. I mean, eventually, probably your code base includes usually more than a few coding languages and frameworks, and today it also includes usually infrastructure as code, and it doesn't even have to be one. You might be use Terraform and Ansible and JavaScript and Python and many other languages. Each team writing and using other languages. So it's challenging, and you need to find a combination that will cover you for all of your frameworks and languages that you're using. I can refer you also for that to our blog post, to our blog, because we have some materials around that also. So hope that my answer suffices for the short time that we have.
Wonderful. Thank you, Omer Gil.